Okay, so right now we are going to be done using the Chromebooks. All right, so go ahead and log off, please, and put those away, and then we're going to dive into today's material, try to get that hammered out. Very good. So in your student journal, you guys, today, your notes, you may want to be defining things as we go. You also have your note page. But a polygon is any closed figure. Okay? So this on page 19, it's 1.4, student journal. Okay? Polygon is any closed figure with straight lines there. So there are many different polygons that we could have. The ones that you're most familiar with are the triangle, the quadrilateral. Okay. Notice I just draw the dots. And then connect those dots. Okay, you could have the Pentagon, which some of you look at as the house. Good morning. So Pentagon, this is 5-sided. 6-sided, anyone know what it's called? That is a hexagon. What did Snow White say when she woke up? Hex be gone. Hexagon. Yeah. Come on, dude. All right. 7-sided is called septagon or heptagon. Okay. Hexagon is 6-sided. Hepta or septa is 7. 8-sided is called octagon. So 8 is a common one. I'm not gonna draw it, but octagon. You can just draw the points. 9 is nonagon. 10 is another. Good, decagon. That's kind of that's one we use a lot. What's 12? Dodecagon. Okay, dodecagon. 11, you guys really, after we get past 10, with the exception of 12, we'll just call it like an 11agon or 13agon or 14agon. Okay, it's a polygon. The polygon after that. I'm sure they have special names. We're just not going to use them there. A side is a segment that connects two vertices but is not a diagonal. Okay? It's on the exterior connecting two vertices. So for instance, this is a side. This dashed line is a diagonal. So a diagonal is a line that connects two vertices but is not a side. Okay? A vertice is a point, so this would be a vertex. It's one of the corners of your figure. An n-gon, so that's where I said like an 11agon, so 11 sides, we'll just call it n-gon. Okay? So 13agon, so on. Concave and convex. So those two terms. Convex means your diagonal all diagonals lie within the shape. Okay? Another way to think about it is I like to think of concave. So if I make a shape here, a hexagon, or excuse me, quadrilateral. 1, 2, 3, 4. That is a concave. Notice it has like a little caved in part. It's caved in. There's like a little cave. If you were out camping, you could kind of like hide in here a bit. It's a cave. Okay, it still fulfills like this is a diagonal right here. It connects this vertice to that vertice. But that diagonal's on the outside. That's concave. If it's not concave, then it is convex. It's one or the other. Convex, all the vertices point outward. All diagonals lie within. Concave, a diagonal, one of your diagonals, at least one, would be outside. And it has like a little caved in part. Okay? It's like someone got mad and punch the shape. Okay, you got upside. I know, poor shape, man. They like crush the little box or something. Okay, or maybe if you've ever been at one of those fairs where you try to hit something really hard, it tells you how many. You guys know what I'm talking about? It tells you how hard you hit it. That's kind of you kind of caved it in there. Okay. All right. So some notes here. Core concepts. Core concepts. Remember, that's your Common Core stuff. But it talks about the size, the vertices. This is polygon A, B, C, D, E. Notice we just keep lining up the letters depending upon how many sides there are. Okay. Any questions there? All right. So what I would like to do. Oh, and one other thing. Please remember this is our title. Okay. What I'd like to do is I'd like to go through some of these monitoring progress. I want you to first classify it by the number of sides and tell whether it's convex or concave. Go ahead and talk with your groupies about it. Answer that question. Number one, what type of shape is that? It is concave. It is 1, 2, 3, 4, 5, which is a pentagon. So it is a concave pentagon. Number two, concave or convex? Convex. Yes, convex. You cannot connect any diagonals that would lie on the outside. This one, on number one, the diagonal was on the outside. And how many sides? 1, 2, 3, 4, 5, 6, 7. It is a heptagon. All right. Any questions? All right, moving on. Number 3, let's find the perimeter of the polygon with the given vertices. Now, this is why I gave you the graph paper, and we're not going to do all of these. We are for sure going to do a couple of them. So let's try number 3 to begin with. Make sure you take your piece of grid paper that you picked up on the way in and plot those points. Okay, ready to go. Actually, let's do number 3 and number 5. Okay. All right, number 3, when you plot those points, you get this shape. Remember, vertical and horizontal lines are easy to find distance on. This gives you 1, 2, 3, 4, 5, 6, 7. This gives you 1, 2, 3, 4, 5. Then how do we find this length? Could use the Pythagorean theorem or the distance formula, right? A squared plus B squared equals C squared, or yesterday we used the distance formula, D equals the square root of x2 minus x1, quantity squared, plus y2 minus y1. In fact, if you didn't want to plot any of the points, you could use the distance formula on each of those. Find the distance from here to here, distance from here to here, and distance from here to here. Now, it seems like a little easier to plot them, and I'd probably use the Pythagorean theorem here. Just say a squared is 49. B squared is 5 times 5 or 25. So 49 plus 25 is 74, which means this length is root 74. So find the perimeter. We just say, well, 7 plus 5 plus root 74. Seven plus 5 is 12, so 12 plus root 74. You don't have to find it unless it says to round it. You could leave it like that. Simplest radical form. Is there anything that goes into 74 a perfect square? 4 doesn't, right? 16 doesn't. Okay. 25. 2's not a perfect square, yeah. So you just testing your perfect square. So, bless you. So you'd be done with that. Okay. If you rounded it, you'd rounded the nearest tenth on side length. Okay, but usually don't round unless they tell you to. Okay. What would the area be on that? That's your perimeter. How do we find the area? Good. Base times height divided by 2. So everyone calculate the area real quick. Or 1/2 base times height. Remember, your base and height come together at your right angle. You get 1/2 of 7 times 5, or 35 divided by 2, 17.5. Good. Now you can put it in decimal form if it terminates. Okay, terminate means the decimal ends. There's like 0.3333333. You have to leave it in fraction form. Okay, any questions there? All right. Hey, last one we're going to do together here. This guy right here. This was number 5, monitor progress. Okay. All right. What's our base? Anyone? Yeah, it's 5. What's this? Happens to be 5 as well, meaning these sides are going to be, we have equal here. Well, on this, if I wanted to find the length of that side, I can make a little right triangle in there. Okay, so if you kind of make that right triangle and maybe draw it a little bigger over here so you can work with it a bit. That right triangle, we're trying to find this side length. That's here. And it's going to give you the same length as that side. So what's this length of the triangle? Looks like 2. What's this length? Yeah, it looks like 3. So 2 squared is 4. 3 squared is 9. 4 and 9 is 13. That means C is root 13. So this is root 13. This is root 13. So my perimeter is 5 plus 5 plus root 13 plus root 13, or the other way of writing that is 10 plus, how many root 13s? 2 root 13s. That's equal to our perimeter. What's our area? Tell your neighbor how you find the area of a parallelogram. Okay, volunteer? Yeah? Yeah, it is just base times height. Hunter, right? All right. Yeah, area is equal to base times height. Now remember, base and height have to meet at a right angle. Okay. Yeah, Drew? Yep. Yep. No, this is, yeah, so we'll go base is a length of 5. And our height is 3. So our answer is 15. Yeah, and it would be square units, but we haven't really looked at labels yet today. So. Okay, any questions? All right, your assignment today is nowhere to be found. Oh, found it. Shoot. Man, that would have been a bummer. Okay, here's your assignment. All right, get that out to you. Remember, it's due when?